everyone, and welcome to the 17th Sustainability LunchTalk. Can you hear me? Good? Perfect. This LunchTalk will be recorded and uploaded to the sustainability webpage in the coming days. Please be aware that we will not take questions during the presentation, as a dedicated Q&A moment will take place at the end of the presentation. If a question pops up during the talk, feel free to write it in the chat. My name is Mathieu Gilieron, and I'm the project manager for sustainability for the University of Luxembourg. With my colleague Laurent, one of our missions is to raise community awareness on sustainability. To help us, we are surrounded by brilliant experts in teaching, research, or administration, and we also have a network of passionate and dedicated experts. Today, we wanted to highlight Laurent, founding partner of the IT Business Service Provider Innovation and board member of the Association in IT. Digitalization has been buzzword for years now, and it is often associated with sustainability transition. But digitalization does not mean dematerialization. Quite the opposite. The proliferation of digital technologies comes with significant environmental consequences. The energy consumption of the digital sector, already equivalent to 3 times the annual use of France, grows by 9% yearly. The water consumption of artificial intelligence could represent 4 or 6 times the consumption of Denmark by 2027. As the demand for devices and data centers increases, along with constant innovation in the sector, the pressure on natural resources is only expected to intensify. While digital technologies hold the potential to support sustainable practices, they must themselves adhere to sustainable limits. To address this challenge, we must carefully assess the environmental costs of digitalization and make thoughtful choices. Our co-host for the day is Dr. Benoit. He will moderate this talk. He is a research scientist, part of the research team of the Department of Computer Science at the University of Luxembourg. His current research interests focus on software engineering methods and tools to model and predict natural ecosystem restoration. He recently launched an innovative lecture on green IT and IT for green for master students. Without further ado, Benoit, the floor is yours.
Okay, thank you, Mathieu. Okay, so we could not hear you so well. In your introduction, there was like a kind of robot voice, and in the chat also was saying. So I hope you can hear me better, and that also you can hear Open better later in this presentation. So let me just do a very short introduction. So today we're going to explore a big question: digital technologies, ally and NMI of your sustainability journey. So with Aubin that's going to talk. So a few background concepts. So what is sustainability? So sustainability is about finding ways to meet our current needs without harming the ability of future generations to meet their own needs. Okay, so this is very general and large. And digital technologies, of course, they play a big role here. Let me tell you right now that, of course, this topic is so vast that in 20 minutes of Aubin presentation, and we're not going to be able to talk about everything. So the focus of this presentation is really mainly on environmental aspect of sustainability. So you have on the one hand, IT for green, where technology helps us reduce waste, save energy, tackle challenges like climate change, etc., etc. And on the other hand, there is also this carbon footprint of the digital technology itself. Things like, as you were saying, Mathieu, intensive data centers, electronic waste, etc. That's where green IT comes in, focusing on making technology more eco-friendly, let's say. To illustrate these aspects, IT for green and green IT. So Mathieu, you gave already a few data, but I will only give you 2 data. One that is coming from a recent report estimating that IT has the potential to help cut 10 times more CO2 than it emits. And the second data that is on the other side is that the annual world electricity consumption of data centers, okay, 1 year of data center world electricity consumption is equivalent to 75 years of Luxembourg electricity consumption. This gives you a rough idea of the scale that we are talking about here. This data, of course, it illustrates that IT may be both an ally and it can also be an enemy. Let me finish this short introduction before Auban takes the lead by informing you that my research at the Department of Computer Science is directly tackling these issues, and that I have set up a new lecture, as Mathieu was saying, in the Master of Computer Science, in which these concepts of green IT and IT for green are discussed and applied with the master students. This lecture is quite recent and is now running since 2 years. And even though it's optional, it's already a great success. So now let's come back to our lunch talk. So are digital technologies allies or enemies? Our speaker, Aubin, will explore this question, and let's get started. It's your turn, Aubin.
Yeah, thank you, Benoit, and thank you, Mathieu. I hope you all hear me well as well, and not with a robotic voice, because it's a human-powered presentation. Yeah, so as Benoit already introduced, so about sustainability, one of the interesting framework to measure, let's say, sustainability is the Sustainable Development Goals. So you may know they are provided and promoted by the United Nations. They encompass 17 goals and in details 169 targets. And as a study showed that AI may have a positive impact in up to 80% of almost 80% of these targets, whereas it may raise negative impacts in 20 to 35% of the whole targets. So these targets are mainly in terms of inequality, but also regarding environment, access to energy, so environment and people, access to energy and to water. So what is interesting when we talk about environment is to have this notion of planet boundaries, which means what the planet and the resources, the natural resources on the planet are able to support our human activities. And if you look into this schematic representation, you see that technology affects individuals through the technical developments which change the way people work and interact with each other, and with the environment, whereas individuals will also interact with the technology through new needs to be satisfied. Technology, including the technology itself and the developers of this, affects governments through new developments that need appropriate piloting and testing. You know about the AI Act, for instance. Also, technology developers affect governments through lobbying and influencing the decision makers. And the governments provide legislation and standards to technology that affects the individuals through this policy and legislation, and individuals will also require new legislation consistent with the changing circumstances from the governments. And the environment in all of this interacts with technology by providing the resources needed for technological developments. We will see that a bit later, and is affected by the environmental impact of the technology itself. So furthermore, the environment is affected either negatively or positively by the needs, impacts, and choices of individuals and governments, which in turn require environmental resources. What you need to also to see is the the thicker the arrow are, and that means that the faster the change is. So you can see also this inequality between for instance, between individuals and environments. The needs change faster, so that means impact as well. Then what the environment may also turn back to the individuals. Let's have a focus on electricity, because this is one of the key, so of the major concerns for a lot of current discussion. You can see here, for instance, what may imply to embed AI in a current existing digital service. Here, the case is a web search service. Before, so in the classical way, that means with a keyword search system, to an AI-powered search engine, you can see that the consumption, so power consumption for a single request may increase by tenfold. And you probably also read a lot of news regarding these concerns about energy. For instance, you have Goldman Sachs, who predicts a jump by more than 165% by 2030 of the data centers consumption. And mainly due to AI demand, so capacity demands, whereas only about 40% of this energy may come from renewable sources. And this is quite in line with the increase that that was mentioned before. Another point, another concerns come from a real estate advisor, and oh, sorry, it should be on the right way. Look. Yeah, yeah. From a real estate advisor who warns about the potential obsolescence of the current data center buildings, thanks to the surge of AI technologies, because of the lack of access to the power, the required power. And also regarding the produced heating, so heat, which is much, so AI servers or AI infrastructure is much more thermal intensive, let's say. So the thermal density is much higher, which requires to rethink also the ventilation and the cooling management systems of these buildings. And you may also had a look, sorry, you cannot see that on the right way. Here, an example of a brand new data center that is dedicated to AI technology computing, located in Memphis, that was required to more than that required more than 100 megawatts of power to be fully on a 100% workload. But at the date it was launched last August, the grid, the energy grid, could only provide 7 megawatts to this data center, to this new data center. And to overcome this situation, you can see on the picture this Volt-Grid or mobile generator that was deployed on site. And you have to know that these generators works based on natural gas to produce this power. And it was done without any permits to do that, especially regarding air pollution and the concerns about the political city. So the local city was raised, and there is a claim about this point. So where does this energy and topic come from? So let's start from where you sit when you use an AI service. So in this case, we will have a focus on, for instance, on a ChatGPT like system. So you prompt on this user interface. So that means that behind it, you have data centers that are hosting that are hosting the infrastructure to execute and to make this service available. And you have also IT departments, IT teams that are making sure that these services are running like expected. But before this execution, let's say stage, so the usage stage, some engineering teams had to proceed through a lot of tests, and they built a model like the one from ChatGPT. You have to know they are compiling different complex algorithm patterns and so on to build this final solution. And to do that, they need a huge amount of computing and memory resources. So that are provided again by the data centers mainly. Uh, don't also underestimate the networking, the traffic, also because this is a highly highly data intensive activity. So that means that there is a lot also of data to transfer. And before doing this testing and composing phase, let's say, the blood of this stage is, of course, the data. And you need to understand that the volume are really gargantuan to train these models. And these data, to be digestible, need to be prepared for instance, we call that to tag or to label them, to give them, let's say, sense. And this is mainly done by humans. And that raise some concerns regarding the what we call the digital workers, so the click workers. They were OpenAI, for instance, buy some people, so buy services to microtasking platforms where people that come mainly from global south to review data and to say whether it is, for instance, acceptable, not acceptable, whether they see a dog or a cat or a flower and so on. And that's on a very high scale, of course. But there is also the situation where they need to label data regarding appropriateness or about the violence or some harmful content or not. So that means that these people, they are also exposed to a very large amount of pictures or texts that are really harmful for their own psychological balance. And now we saw, let's say, the service layer, but inside the data center, you have all the servers and computers and network and equipment, and also regarding your own user devices. So let's have a look inside this the life cycle of equipment. So we start at the let's say usage phase, where you are using this all these services and devices. To make them available and running, I mean, You have, we already talked about that. You have a lot of people behind. You have all this networking infrastructure, so the internet infrastructure around the world, with a lot of cables, of equipments, and so on. And you have the data centers. But before this usage phase, you need to build the data centers itself on one side, and on the other side, of course, your devices may be shipped to you, because as you know, there is very few equipment that are really manufactured, let's say, on a local way. Um, One thing regarding this shipment and also the packaging regarding your equipment, there is a lot of communication done by the manufacturers and vendors about the, let's say, sustainable actions they are doing on their products, and they focus this communication mainly on packaging and on packaging. You have to know that if you look at the overall impact also on the multi-criteria, so I mean water, resources, electricity, and so on, you have to know that the packaging footprint is less than 2% of the overall footprint of an equipment. So we could quietly define that as greenwashing, or at least that could be subject to some questions. Before it is brought up to you, you have the chip and the servers, so the server boards, and the chipboard to be manufactured, done by people far from our human rights convention and so on, and that this phase also consumes a lot of electricity, a lot of fossil energy, so fossil fuel, and also water. And before these chips are manufactured, we need to extract a lot of a huge amount of land to get the minerals and the materials that are required for our smartphones and so on. And this is another step, so the first one at least, where we consume a lot of water to make it clean. So the minerals and the metals that are extracted, and the discharge water is also very toxic in the end at this mining activity. So this was the stages before. So to summarize, the first one, so extraction of resources, then manufacturing the chips, building data centers and all the equipments that are required, like air conditioning, chillers, and so on. The shipment, the shipment. Then the usage phase. This is the one you let's say you see. This is our day-to-day reality. And after we used it for a certain time, then you have the end of life of these devices and equipment that needs to be managed. You need to know that regarding the e-waste, so the electronic waste management, worldwide, about only 27% of these equipments are correctly collected. This is a bit more, so this is about 40% if I remember, in Europe. So it's let's say not as bad as a worldwide average, but it's far from being let's say good as well. One short focus, for instance, about water, because to come back on the sustainability and this question, or this affirmation of is digital technologies ally or enemy regarding sustainability journey. So if we look at the water, for instance, the sorry.
Auban, on t'entend plus, hein, t'as pas remis de mute.
Oh, sorry.
Ouais.
Come back on this. So on the good side, let's say of application of digital technologies and especially also AI technologies, we can see, for instance, the agricultural sector, where, for instance, we can optimize the usage of water thanks to different sensors and some computing and data collection and computing of this to automate also and to predict and so on. Another case that can be also seen is regarding the toxic water, to have some sensors, they call that biosensors, that can also capture some data regarding the composition of the water and alert the consumers whether the water is consumable or not. These are example of let's say good application of digital technologies. On the other side, the concerns, so let's say the negative impacts regarding this water resources are, of course, regarding the data centers, because they need to be cooled, and more, and especially with AI, as mentioned earlier, AI produces much more heat than average servers and computing techniques. That means that more and more AI system needs to be can only be cooled by water-based systems. So that means that the water is used to capture this heat, and there is also so this is the scope 1 water that is for cooling. You have also the scope 2 water that is linked to the electricity production. And you have also a scope 3 water usage and withdrawal. That is about the upstream. That means the supply chain, meaning everything, so all the water that is used during the manufacturing of the chips and the server components and the consumer devices. Which produce a lot of toxic water, so discharge water, with a low average recycling rate. And you have also on the downstream part, which is on the usage of our end user devices that consumes again electricity and as you may see here, using that use also fresh water and so on. So if we have a look on let's say concrete use case, where this is a case where I could support a client of us. It's about using an AI assistant inside the productivity activity and embedded in its productivity tools. The main lesson that we could get from this adoption, let's say, journey. So you have to know this AI assistant, of course, is a generative AI based solution. There is a lot of different AI techniques. If we look just previously here on the agricultural or on the water analysis cases, it may not use this type of technique. And you have also to know that although no AI techniques are neutral in terms of impact, the generative AI technique itself is the most, on the current state, is the most consuming and impactful solution. So that means that here we used an AI assistant to, for instance, summarize emails, to get some support in drafting ones, to summarize also meetings, to generate, so to draft presentations, such type of case. And what we got as lesson, and this is quite aligned with this article I found on Forbes, is that while it may be a game changer, let's say, for time-consuming activities with low added value and low risk, this is not yet appropriate for creativity and complex tasks, or as well activities where the accuracy of the information itself is really critical. Like if you work in as a lawyer in legal activities, for instance. So this is the first point. So it's not directly regarding environments, but we can then ask ourselves, okay, thanks to all the environmental impacts that are behind, does it worth? Well, it's an open question. I'm not here to answer to this question. It's more, let's say, political one. And the other one is also, okay, then now you could save some time on time-intensive activities with low risk and low added value. Okay, but what do you do with this time? Do you take this time, let's say, for yourself, or to slow down a bit your activity, or to stabilize it? Or is it an opportunity that you will take to do more, to produce more? And this is really the question that reflects, let's say, this the so-called rebound effect. No, so I don't know if you are familiar with this term, but we can summarize it like this: rebound effect is when you succeed to optimize something to be more efficient, you use this gain or the avoidance of resource efficiency, so resource consumption efficiency, to produce more, and in the end, you will consume more than previously optimized. So this is the let's say the rebound effect. Let's have a quick look on the second use case. I look at the time. Yeah. This is about the heating regulation system. You know, you can now have, so in the, let's say, smart building or smart house, smart home services, you can have the possibility to connect, let's say, your heating system and to optimize the on-off of the heater, thanks to to different type of data. We analyzed this. That was for a client as well. We did a preliminary study about on the cost benefit analysis approach. So it was not as formal as this, but was the let's say the approach. And what we saw was that, so for a house, if you have the existing system, and then you add all this equipment and solutions to this to optimize the energy consumption in the end of the heater, because this is the initial goal, you will see that you will add a lot of material equipment that are themselves, they consume energy, different energy, but energy as well. And they are also, of course, material intensive equipment. So you need to build, to manufacture these different components. And you need also to connect it to internet. So that means that there is an infrastructure behind that is hosted in data center. And most of them, of course, enables you to connect through your smartphone or your computer to manage your heating system. So the gain, so from a sustainability point of view, that means from a holistic point of view, the potential, I say potential gain in terms of energy, so heating from consumed by the heating system, is not that obvious thanks to all the other impacts that the system needs. And the second point also is, if you use this system, so where is the break even? I mean, how many energy you need to save in order to, let's say, compensate all the other impact? That is the one question we ask. We are not have yet the answer, because of course it's a complex answer. And the second point is, okay, if you would use it to really reduce your, let's say, energy footprint, that's one thing. But you could also use it in order to increase your comfort inside your home. That means that you would not necessarily, you could heat maybe a bit more, or you could have a more stabilized temperature inside your home. And in the end, the energy saving is not that obvious as well. So we could quietly call that so much rebound effect as well. Yeah, so you save some energy, but you take it and put it on more comfort than before. So it's not that obvious that this type of system are, let's say, positive in terms of sustainability. Of course, so we could not see all the, let's say, the different dimensions of sustainability of digital technology and transformations that may raise. You have to also to be quite aware that there are challenges regarding the data that are used to train these models and so on. Of course, there is also a challenge regarding the transparency of how it is built, how it is hosted, how it is used, and how the data also are selected. And regarding social aspects, there are lots of regarding education. You are on the on the front line of it, and regarding the society, the work, and so on. But could not see everything in 20 minutes, like it was said, and a bit more now. From the last slide, what just I wanted to summarize for you is to be let's say, to start to embed sustainability consideration, let's say, into your digital transformation plan or your IT, so digital projects. What could make you more aware of that is first to know, to have better knowledge of the concrete impacts of the system you are building or you plan to deploy. Then ask yourself whether where there would be some resource gains. Whether there would be some resource gains, of course, except economical one, it's a voluntary put aside. And other questions that we did not go further was about the dependency of you will create using new models, whether they are closed or not. And how do you make sure that the gains you aim to have in terms of resources, so on the sustainability point of view, how do you secure them? This is also one of the key question to be asked at the very early stage of the project. If you want to start this let's say, sustainable digital transformation approach. Thank you.
Thank you.
You're on
Thanks,
mute.
Aubin. Yes, yes. Thanks, Aubin, for the presentation. So now it's time for questions. So I have seen there was Igor who make a comment. So maybe Mathieu, you can be in contact with him, because Mathieu is how to say, having link with staff members of the university, and you can directly see with him. And there's a first question by Elvira, who says, do websites or applications exist that compute or concrete AI impact? You are mute. We don't hear you, Aubin.
Do you want maybe to answer to this, or
No, you can go ahead. You can go
yeah?
ahead.
Okay, so it starts to have some, but to be honest, the main problem we currently have regarding measurements and evaluation of impact is the lack of transparency, as I mentioned earlier. Transparency regarding and access to the data. I mean, when I see access to the data is okay. How is the system configured? What is the IT equipment behind it? What are the resources that has been used to train the model, for instance, and so on. So for the moment, there are let's say there are some papers that do estimations thanks to extrapolations or proxies and different ways, but we don't have currently any way to take, for instance, a website and put it into a calculator, for instance, or an estimation system that will give you the okay, it's an F energy performance in labeled or something like that. Not yet.
Okay, so I can complete just a little bit, because in the lecture we have some practical exercise, and there are some websites that exist, but it depends really what you want to focus. So we could share that. I don't know how. I don't have them directly in my mind because we focus on presentation, but there exist some where you have mainly the complexity of the website that is taken into account, and then this complexity of the design of the website will be analyzed, and then based on this complexity, there will be some kind of carbon impact that is computed. Okay, so
and just regarding
yeah.
this, on this point of view, of course, there are some indeed there are some calculators, but let's say the problem of this, or the limitation, I would say more on this, is as we don't have data of the backends of the servers that are running those websites or applications, and maybe the AI that is embedded into this. This is really the limitation to have such let's say a reliable impact measurement, I would say.
Yeah, and yes, I can also. I mean, okay, we won't do the whole thing on just this question, but I've seen also some papers. So academically, there are some people starting to analyze the models and be able to actually evaluate them before even the training. So to be able to evaluate in advance what will be the cost of impacting of learning, of making the learning phase and then the usage phase, etc., without having the learning done. So I have also a little question, because you are from my own, you are working directly with companies of the greater region. So how receptive are your partners when talking about digital technologies and sustainability in particular? Because what do you think are the biggest challenge in this area with your partner, the concrete local, greater region partners?
Yeah, so in the greater region, there is a quite different situation. You have on one side, you have in France, where they have been quite, let's say, on the forefront to put some legislation regarding accessibility, of webs. For instance, you have different frameworks and also laws that restrict, so that that oblige some companies to be aligned with specific frameworks. You have also for the collectivity, so the public public collectivities. You have what they call the REN, R-E-N, EEN, I mean, which is a regulations that theoretically oblige them to do this sustainable, so this green IT assessment, and also on social aspects, if I'm right, mainly on the accessibility prism. But they don't. There is no sanctions if they don't comply with this. So that means that, of course, you have some that play, let's say, the game, but not all. In Luxembourg, there is no specific law framework or legislation regarding this, except, of course, those from the European point of view. So that means that the let's say the awareness is average, not very high, to be very honest, in France, Belgium, Germany, and Luxembourg. Maybe a bit more in France on the public sector, I would say.
Okay, thanks. So Mathieu asked a question for both of us. So from academic and industrial point of view, when the environmental impact of IT become a subject for discussion, and was it discussed during our studies? So I can start, and maybe and then you can go on. So me, it was not at all discussed in computer science studies. So this was 20 years ago. I know that some universities start to include this in current topics in Master of Computer Science, but other masters, of course, other thematics. And then, so concretely, it's rarely talked about. I mean, in Department of Computer Science, we don't have this kind of discussions. It's not a typical discussion. So this is not in research, except if you go into the niche of researcher doing research on sustainability, etc. But it's not yet really like everyday life for our work. Aubin, what's your during your studies? Did you learn?
During my
Was it?
studies, it was almost also 20 years ago, and there is no word about that. But what I learned far later is that where during my studies you had the let's say really the pioneer of what he started to call green IT, which is Frédéric Bordage, located in France. Who
Yes.
started this initiative in 2004. So that means that the topic exists for quite a while, but it really started to gain attraction, I would say, during the pandemic, where more and more people were asking themselves, okay, but we are digitalizing lots of things because we could not meet physically and so on. And what is the impact of all of these digital services? And this is, so from my industrial point of view, this is the, let's say, the breaking point where I really started to where I could start discussion regarding this. Before it was really taboo, especially in the IT sector. Because also of this belief that, and we still use it, that digitalization is a way to dematerialize I mean, Mathieu said at the very beginning, it's not immaterial, it's concrete and very hard material. All these digital, it's not virtual, I mean. And this is why, from my point of view, this is quite taboo still now, and especially with AI, with all this hype with a lot of economical hopes. This is quite difficult to speak about the
Yeah,
other side of the coin.
it's clear. So it's like we are blind and we don't want to face the truth. But now technology is everywhere. We are dependent. So now what? Now what are we doing? So and that I
Yeah.
think we need to face the problem and really see what is our real impact and how we can improve that. Of course, I mean I think we both agree on that. But the time is kind of running up. So I don't know if we have a time for the last question of Laurent, Mathieu, or is it already time to close? Yes. Okay. So Laurent in the chat talked about the minerals that are used when you were talking about the extraction of minerals. They are used, these minerals, actually not only for IT, but they are used in many things in IT. So terminals, data centers, storage, etc. So this competition in using these minerals, actually, they are for all they are needed everywhere. But how do you see that we could decide where these minerals should go? And do you have an idea on that? I mean, something to say shortly
That,
because we don't have so much time anymore.
yeah,
So.
and I would say that would be a dedicated topic for next lunch talk, because
That's a joke, yeah.
it's because it's something that is quite let's say political, and there is a political point of view also, and whether from which framework would you consider that this need is better than another one, for instance,
Yes.
you know. And this is really tough work. I have, of course, a personal point of view, but I am not here to to express it. This is my personal yeah.
Okay. Yeah, okay, well. Surely you have an opinion.
Yeah, I have one, but I will keep it for private
You don't want to
discussions.
talk about it. Okay. So maybe Mathieu, I let you. There is not more questions, so I will not start a new question.
Can you hear me now?
Yes, I can hear you, but I cannot see you. But
I'm trying a new way because my for some reason my computer is not working. I would need an IT guy, but they are all watching this talk, so I guess
Yeah, we are quite busy now.
So yes, thank you, Aubin. Thank you, Benoit, for this talk and your insight and expertise on this important topic.
Thank you,
We hope
Mathieu.
you all enjoyed this presentation and discussion. Once again, the record of the presentation with the amazing sound effect that I used at the beginning, not thanks to AI, just thanks to bad tools, will be available online on the sustainability page of the University of Luxembourg. Before closing the WebEx, I would like to invite you all to our next Sustainability Lunch Talk on March 19 on the subject Communicating the Science of Climate Change to Business and Society with Potential Solutions. It will be presented by, once again, an external guest, Perses Billy Moria, who is founder and CEO of Earthsol Bioproducts, the first compostable and biodegradable product manufactured from India. And it will be together with Dr. Pranjul Shah from the University of Luxembourg Incubator. Don't forget to visit the sustainability webpage of the University of Luxembourg to learn more about the coming lunch talk and all the projects we have at the university. And don't forget to subscribe to our sustainability letter. You can actually find in the last one of the last year's sustainability letter a very nice interview of Benoit explaining a bit more again about green IT and the green IT class and IT for green. Thanks a lot again to both of you and to all of you, and have a nice day.
Okay, thank you, Mathieu. Thank you.
Bye.
Thank you, Aubin.
Thank you. Bye.
Bye-bye.